This is CheloniaCast, episode 69. Today we are joined by Dr. Justin Congdon, who's a professor emeritus at the Savannah River Ecology Laboratory based at the University of Georgia. Dr. Congdon has done an incredible amount of work on the general ecology of North American turtles, and specifically snapping turtles, blandings turtles, painted turtles, but some other species, just with incredible amount of long-term data. He's published and co-authored over 180 peer-reviewed publications with just incredible amounts of data and over 6 book chapters, his authorship on that. And so we're really honored to be talking to him today about some of his work and future directions. And so thanks for joining us.
Well, thank you for asking me to do this. I'd love to talk turtles.
Awesome.
All right, so to kind of kick things off, what first got you interested in turtles? It's always a good question.
Okay, and this time it's short. Don Tinkle,
Oh,
University of Michigan, at that time director of the Museum of Zoology. I was at Arizona State as a PhD student when he showed up, and I got a chance to take a class from him on evolutionary ecology. And I loved the class, and I had, I think Thursday and one other day off, and he was doing lizard studies just north of campus. And so I said, well, I'll volunteer just both days. You can count on me, I'll be there both days. And so I started going up with him, and we did the work together, and it was fun. I had been a mammalogist, a budding mammalogist up till that point, and I fell in love with the lizard stuff. But then, as I did my PhD and I got closer to the end, and I kept working. Oh, then coming home one day, he said, "Well, Justin, if you're going to keep working for me, I better pay you." Thank you. I had shoes with the cardboard in them.
yeah.
Field shoes with cardboard in the bottom. Anyway, and then so I kept going with him, and I did all sorts of physiological stuff because that's what I was going to be, a environmental physiologist. But anyway, one day he took me home, and he said, I was sitting on the hood of my car, and he was leaning against his, and he said, well, Justin, what would you think about being involved in a 20-year study of turtles on the George Reserve in Michigan? And I tried to pretend I had to think about it. I didn't do a very good job, but I said I'd love to do that. So then my goal became get your doctoral work done, but become a postdoc at the University of Michigan Museum of Zoology, which is like really good. And so went back and started the turtle work. And the first day, got the truck backed up to the Hill and Dale house, which is right in the center of the George Reserve, where Nancy and I lived for the next 4 years. And the caretaker was there helping us unload, and Don comes and says, come on, I got to show you where the traps are. I'm leaving for Arizona tomorrow. So we go out, leaving Nancy and them to do the work there. And we went out and checked traps, and I went, oh, I like this. And then he left. He gave me brief descriptions of the data sheets and all of that and what we recorded, and showed me. And anyway, he left. Next morning, I got up. I went out and got in the truck and drove to the wetland, and I get to this gate. There's a south gate and a north gate, and I was supposed to go to the south area where there are 3 wetlands. I was at the north gate, and I'm going, what happened? Anyway, and then I realized this has got to be what they talked about the north gate, so I turned around and went back. But that's how much I knew about the George Reserve when I got started.
Yeah.
It was just slam dunk. And we had 12 traps then, borrowed from Whit Gibbons, and a mix of sizes and shapes and so on. And the next year, when he was gone, we had ordered 30 traps, I think, and we had them, got them during the winter. And he left, and I built the poles for them and got all ready, and not only did the west area, but went over to East Marsh, which nobody previous had worked on. And anyway, we had our first 100 turtle day while he was in Arizona. that was a treat to call him the boss, and say, well, we did 100 turtles today. And he, of course, didn't believe it, but we did. So that's how it started, and I didn't find anything bad about it. And I can tell you, we fenced 2 of the wetlands, and there were 1.4 kilometers fences around the whole perimeter. And then East Marsh, when I got over there, it was the last year of my financing, and I had to make a choice. Do I blow the money and we won't have anything left till next year and fence this thing or not? And I said, well, I gave it the best shot on the grant proposal, so the hell with it. I'm just gonna build a fence. And so we put in about half of the fence that fall. I got the grant, and then we finished it in the spring, and it was the best thing I ever did. We had doors, gates, all around there, so you could open the gates they had plywood sheets in some of them and fencing in some of them, the larger ones. And we closed them every morning at 6 and opened them when the turtles were done about 10 at night. And somebody walked that every half hour from 6 in the morning until we were done. And then, of course, you had your other nesting areas all around it to search too. But that was our schedule, 6 a.m. till the turtles are done, 7 days a week, rain or shine. Didn't matter, we were out there, and that's what made it work. Right. And Don Tinkles, when he was dying, he was literally within a couple days. I was sitting with him, and anyway, he said, Justin, whatever you do, keep your focus on the reproduction. I said, well, certainly. I'd never even thought you could do a life history thing without reproduction. So I said, yes, I will. I can guarantee it. And so we did that, and that's what made it different from a lot of other studies.
Right. And the George Reserve has a pretty rich history of turtle ecology, even going back to before when you started there with Wilbur and such. And
the first person to work on there was Owen Sexton, a PhD student, 1953 to 1957. He marked about 500 to 600 turtles, and he published on painted turtles and blandies. No snappers. And then Henry Wilbur came 68. He was a Michigan fellow, and he did another 5 years from 68 to 73, and that's when the period when Don was director of the Museum of Zoology, and so they talked a lot, and Owen Sexton had given his data to Henry Wilbur, and Henry Wilbur gave both of their data with Owen's permission to Don, so we started out with that data. So we were 1,000 animals ahead, and a bunch of years for aging and so on. And the old lady, and I don't know tell me if I'm going too far, but the old lady was 95 last year, and Matt Cross is here from the Toledo Zoo, so we're just going to check the traps. Phone call rings, it's Matt, and he says, hey, you mind if I come visit? And he'd been there before. We really liked having him. And, come anytime, So we go out, check the traps. It's about 40 minutes, 45 something from Ann Arbor to the George Reserve, and he was up from Toledo. And anyway, so we're there, and we just happened to gotten the old lady, so we had her up at the house, and we were taking pictures, and we were, measuring everything and so on. and he pulls in, and so we're there, and if he'd have been 10 minutes later, it wouldn't have happened, because we would have already been down there letting her go. Anyway, so the guy, the lucky guy that you have come visit said, "You want an X-ray?" I went, "Sure, I'd love to have an X-ray." He goes back to his car and he brings a $48,000 portable digital X-ray on the front porch. We set it up in minutes. Goes right to his phone,
Wow.
and she had 11 eggs.
Wow.
And we had recorded her as reproductive before, but we never had that record because we quit X-raying in 2007 because we have thousands of X-rays of gravid females, and it didn't. And we were having trouble finding people to develop them because we still had the old cassettes and
Yeah.
the old Min X-ray machine, so we didn't do it. Of course, I asked him what it cost, and he said, told me, and I went, "Oh shoot, I was thinking of getting one."
Yeah.
No way.
Yeah. Right. The technology is really useful.
So the last thing the technology, I just am envious of what's come along that you can do now that we couldn't do it.
Right.
But about what kept it going and so on, I can tell you, I'd be on that fence at 6 a.m. and in the beginning, all the reproductive birds are singing and the males are courting, and the weather is just gorgeous or not, didn't matter. I didn't mind any of it as long as we were getting turtles. And I'd go, somebody's paying me for this. I'm actually getting paid to be doing this that I love to do. And how lucky can you get? And so that was basically what kept it going, is most of the people that then joined the group as more permanent than 1 or 2 seasons. There were 3 of them: Roy Nagel, Owen Kinney, and Todd Quinter, who've they have more years in collectively than I do, and they're indispensable because I had to run the east side and the west side, and I only wanted to be on the east side, and you couldn't do both. And so when they joined in and added to it, I could leave the west side. I never had to think about it again.
It takes a team.
Very
right?
dependable.
Yeah.
Very creative and dependable people.
That's good. That's really interesting. And so the first major kind of publication that came out from your work at the George Reserve is the 1981 demography of painted turtles. And
With Don?
yes, and that was just kind of fascinating because it was the second time that a life table had been produced for turtles in general.
Totally wrong.
Is it? Yeah.
Not totally wrong.
Is it? There were more.
Very wrong.
Okay.
It was based on an assumption that all the painted turtles were producing 2 clutches of eggs.
Interesting. Okay.
And they don't do that. And not only that, those that do it don't do it every year.
Huh.
And so those are the fine points and the relationships to body size and age that make all of this, what we've produced is a mechanism-based data set, not a pattern. And what patterns show you, and most of the growth models are pattern-based. I mean, or not some are pattern-based, and the conclusions are all pattern. They don't have any mechanism for it. The model doesn't tell them what's going on to determine mechanisms, and I'm a mechanism-prone biologist. I don't like patterns are great. They allow you to form questions, but they don't tell you the nitty-gritty with it. And with turtles, my God, they're full of surprises.
Right.
Just absolutely full of surprises. Lots of surprises left.
Right. And it just ecologically, they're really fascinating. And over the course of your career, you've dealt with the sort of evolutionary perspective. And I guess I mean, I don't want to try to put into words what you're saying, but you look for kind of the data and then try to find what evolutionary sort of processes are creating that situation and why it's beneficial to the organism. And
Yes, how a pattern and relationships between body size, clutch size, age, and that, how it influences reproductive output, which is one of the key things you put in a life table, and the Euler equation for doing that, the step up from there. And you have to have it, and it's full of little differences in things. Well, take painted turtles, produce one clutch, capable of 2 clutches, and 5% of them produce 3 clutches. We didn't discover the first third clutch until probably mid to late 90s, somewhere in there is when we got the first third clutch. And fortunately, the marked turtle had been caught every time, which is, the square of that, square of the both, so on, the diminishing probability that you could do that.
Right.
But we did it, and she had been marked by Sexton, by Wilbur with a plastron mark, and then we marked carapace marks. And so she had both marks, and both marks were at all 3 captures. So no question, I was so happy with that. That's just like concrete. That's what I like.
Right. Yeah.
So yeah, and in the paper on aging, and the papers on male reproductive success, the big thing with male reproductive success, a lot of it's based on the quality females that they mate with. And there's 25%, to the best of our knowledge, out of East Marsh with the fins, that produce 1 clutch a year over a lifetime. They never produce a second clutch.
Huh.
Most of them produce 2 at different frequencies, and occasionally 3. But this one group in there, it doesn't do it. And then I have to ask, how could natural selection leave that in them? I mean, you double your fecundity every time you produce a clutch of eggs, because first and second clutches are essentially identical in terms of number of eggs. So it's all the excitement of seeing those relationships and all the details that change the way you would interpret things, importantly. And so we redid that life table with a lot of newer data. It's still not complete, but the life table, the second life table, was way better.
Interesting. And yeah, it sort of brings to mind this bet hedging strategy that it seems that a lot of the turtles in the George Reserve may have sort of demonstrated that, but perhaps that changed with time. I'm curious.
My interpretation of it did.
Okay.
And bet hedging is, I don't even remember the last paper I've seen on bet hedging. It's been a long time. It just doesn't seem to be very good at getting data to support that they're actually doing a bet hedging. Though they could, but the data aren't there to support it. And the problem is if you're hedging bets, what are your bets? And how can you predict one from another? Or you just constantly do that, and the turtles don't constantly do much of anything. They do whatever happens. I'll tell you just one story quick. So East Marsh is going dry. By the time end of the nesting season, when I had to go earn the money to pay for the next year, it was about a third left, and there was no prediction of rain. So I had a couple people stay there, and they kept calling me. Well, it's down another bit, and it's down another when there's only this much left down at the dam, and so on. So I start making predictions, and one of the predictions was that we'll come back this year, and this is really important. We need to get all the clutch sizes we can, because the quality of the marsh is going down. The whole thing's going to collapse, particularly for painted turtles with multi-clutches. So it came up that year. The marsh got winter rains, and it looked normal again. We set it up, and the clutches were bigger on average, because all of the umbra and all of the toads or frogs and everything they eat was put in this package rather than acres, and they just and so
Yeah.
they were all way fine, and that was a surprise to me. I mean, it's just not, I hadn't even considered that, but I was glad that it happened, because that's what happens when you think one thing is going to drive anything that a turtle does. It's multi-cause and lots of correlations and, between traits and how they go up and down. So when you think you've got a trait that should go up and it'll go down, and vice versa. So predicting's still hard, but it's fun. It's fun to be found wrong. It's actually more fun now to be found wrong than it is to say, yeah, it's just what I thought.
Right. What's the biggest, I mean, because you've got an interesting perspective. A lot of your research is just kind of built on, you'd have a 10-year data set and then follow up with a 20-year data set, and then you kind of see the pattern change with just adding more data to it. I'm curious what ecological pattern, what's the thing that stands out to you most that early on you thought it was some kind of way, and then later on you realized this is exactly the opposite or very different than what we predicted?
Well, a lot of the life history, of course, one of the big features is age-specific reproductive rates, age-specific death rates. That's the two of the major life history traits. And of course, they affect reproduction. Obviously, if you die, you're done. And so you have these new data that are changing your estimate of mortality, extending the known longevity of some turtles. That's how we have the Blanding turtle lady. She's marked by Owen Sexton as an adult. And here's how much she's grown since 1954. Almost 60 years. And
Crazy.
she has not grown. And we've caught her 66 times. From Owen Sexton counting Henry Wilbur, and then all of our captures 68 times. So this is not a somebody carved their initials and I found it 20, 50 years later or something, and it's got to be the same animal. This is a really well documented thing. We have lots of x-rays on it. So
Yeah, that's fascinating. Well, talking about the x-rays and just the reproductive ecology and those life history parameters and just the reproductive aspect. Something that is interesting to me is there's so many different dimensions you can look at in terms of egg width, the size, mass, and then, as you've mentioned, the correlations with body size and different features is kind of what you want to get at to place in context the patterns you see with those evolutionary ecological theories. And the optimal egg size theory, the observation that, well, I guess you expect that egg size would sort of asymptote at some point, but the clutch size wouldn't necessarily change. And just curious if that's what you've observed with turtles at the George Reserve, and if not, what kind of evolutionary drivers are causing a different pattern, or why would it be beneficial? It's kind of a loaded.
well, I'll start out with George Williams' quote in his 1966 book, which is still one of the best books on primers on evolution and adaptation. It needs to be read a lot more recently, a lot more. But anyway, in his book, he's the one that initiated the thing that the financial people copped away from him, is drill, baby, drill. George Williams had juveniles, grow, baby, grow. No, I'm kidding, but I think of him, and I would like to put it in his book, because that's what he said. Their job is to get big and escape predation, because every step their mortality rate goes down. So they just grow is the only way you get there, and time is the other component, which is age. If you know the beginning, and so they're getting big as they can, and yet there's a lot of variation in juvenile growth rate even within East Marsh, and so there's all sorts of what 6 or so years you're in there as a juvenile, you're in there this 6, and next one's this 6, or 10 years later it's different 6, and all of things now we're looking at the effective temperature while you're a juvenile on the body size, growth rates, of course, and then body size, and then of course reproduction. If you're like us and we followed the turtles from hatchlings to reproductive age and beyond. That was a great story in the 2018 paper. Juvenile, historically, the discussion about what does a turtle mature at? Does it mature at an age or a body size? And that was it. And there were papers going back and forth about that. And one person would find age, one person would find that. Different species, different places. And then Stearns, primarily, not only him, but Stearns looked at fish harvest, and he found out that in the colder temperatures, the juveniles grow slower. No exciting thing there. I mean, that's why he looked at it that way. And in the warmer temperatures, they grew faster. Yet within the populations as well between it, there was still variation, which is not surprising. I know of no biological trait that's not variable. But the comparative study is, again, a pattern. You don't have a mechanism yet. But he found the pattern that the slower growing animals matured older and smaller, and the fast growing bigger and younger. And so that's a winner take all on both ends. And the people that did those early studies are all pattern based comparative studies. They said it was all due to phenotypic plasticity, and which just means different body responses and different sizes or whatever you're measuring that are affected by temperature. And then we came along and said, well, we get the same pattern in East Marsh, and they're all in the same pot together, and that's not perfect. We're not saying there's not variation. There was certainly variation among the individuals, but the pattern was right there. And then my favorite sea turtle biologist, Karen Borndal, my opinion, one of the very best, and I think it maybe a student Archie-Carr, but at least an associated his. And anyway, she did it, and she did it on captive raised green sea turtles, where they were kept at the same temperature and fed the same diet and got the same patterns. That's cooked in to fish, which were before turtles, and it worked for fish, and it's working for turtles, and I predict it'll be found in a lot when it finally gets looked at. It's an evolutionary conservative trait that works over a lot of time. And think about turtles. 200 million years. You're not responding to a decade. I mean, that's not in their time clock.
Right.
They're doing things like that, and I think if you look, as we just did, I'm not finished writing it, snapping turtle nesting, there's a lot of behaviors that are also, I believe, conservatively, evolutionary conserved traits, that they're not adapting to anything. They're just doing what they do, and snapping turtles, close to 70 maximum age, and blandings certainly 95, we know that, and capable of 100 easily for maximum age.
I'm curious because a lot of your early work too focused on energetics and physiology. I think that gives you kind of a different perspective on ecology from thinking about the energy perspective, and how that kind of has informed your view of turtle evolution, and kind of from the energy perspective, what makes the most sense.
Well, yeah, and I told you, I did doubly labeled water, which is how you measure metabolic rates in free-ranging animals, labeling tritium molecules and oxygen 18. And so you put both isotopes in, and then because water is lost more than one way, and metabolically the oxygen is burned, and that's the way, only way it goes out of the body. It's used up burning fuel, and to support muscles and growth and everything else. And so I did that on Scolopera sharva, a mountain spiny lizard in the Chiricahua Mountains, Arizona. And when I got out, and then Don died at age 49, which was awful for me. I mean, it was like my father didn't bother me as much as Don dying. I mean, it was such a shock. My dad was old. Don just seemed like it over a period of 2 months, and he got diagnosed and he was dead from pancreatic cancer. But anyway, the when I had to then go, oh my gosh, now I got to do this, and I won't have the house to live in because they're not going to give me the house and just let us live there, and we wouldn't know how we'd live anyway. So I started looking for a job, but I got a postdoc with WIT at SREL, Savannah River Ecology Lab, and so I went down there, and it ended up that a physiological ecologist job came, and I applied for it, and so I did my whole spiel for my job interview on physiology and bioenergetics and water loss rates, and mixing it with the life history stuff, and I got hired. And so that was, being in the right spot at the right time. And so WIT was very supportive of me being able to keep things going in Michigan, and so were a couple other people at the lab, so I never got in too much trouble. I did get in trouble, but I did not get in too much trouble. They didn't fire me.
Just your time at the SREL was, that was just different working with sliders predominantly, I imagine. What are some of the highlights from that work?
Well, our discovery late in getting there was how short-lived chicken turtles are. We put transmitters on them in about 4 wetlands, and we had money to do it, and we had the transmitters, we had the receivers, and antennas, and we started doing it, and we kept finding dead turtles with the transmitters on. Of course, it's not hard to find a turtle with a transmitter, so we're finding a dead one here and a dead one there. And I went into WIT, and I said, geez, I don't know, WIT, we must be doing something wrong. I've had transmitters on snapping turtles and stuff up in Michigan. I didn't lose any. We didn't find any. Well, we found a couple, but we knew why they died. But anyway, back to that is we just chalked it up what we were doing, so we went out and pulled all the transmitters off. And then Kurt Buhlman started to work on Diarchilles on the site for his PhD, and he fenced the dry bay where he worked and modeled it after WIT, and also the George Reserve and the way it was constructed and monitored and so on. And he found that he said they're dying. They're just dying at that rate. The oldest one ever found, 21 years old. The next oldest was 16. That's for long-legged turtles. They're not supposed to do that. Well, that was pretty damn exciting. So Kurt and I and WIT published that the life history and so on of chicken turtles, compared them to Blanding's turtles, which was another extreme. And that was fun to discover. We wish we all said we wish we would have known that clear back when I got there, because I swear I might have run out and bought a Carolina Bay, to own it so I could fence it and do just exactly what I wanted to do there. But we didn't know until it was late in the game. But that was good. But down there, any day was exciting with the alligators in Parr Pond, which is a big, huge reservoir, cooling water, with all the reactor stuff. I mean, I worked on radiation. I worked on thermal biology a lot because of the heat. They dumped the heat into the environment. Those reactors did not produce power. They produced nuclear grade, weapons grade explosives, nuclear. So it was a place where I got to say, I had a heck of a budget. You guys all did good for me. Believe me.
Yeah, yeah, right. The Department of Energy budget probably got not too sloppy.
They didn't even. They probably had a little place, SREL,
Right.
whatever they want.
Yeah.
Right.
So we didn't ask for that much, but it was way more than any university setting. I can tell you that. So it was a wonderful place to be, and an entirely different place to be than what I was doing up there. So it worked out really well.
Right.
So the chicken turtle versus Blanding's turtle is just incredible. The extremes. Like why are chicken turtles so short-lived? Like what is the benefit of that versus what does it come down to?
I don't think they have a benefit
It's more
as
just-
much as they have a penalty for trying to live longer, and that is their shell is very thin,
Yeah.
and they only occur in temporary wetlands
Yeah.
where alligators don't live. If
Yeah.
an alligator comes in,
Yeah.
they're gone. They kill them all. One snap and they're gone. Where you see an alligator pick up a slider turtle, slam it, and then pretty soon throw it away because it isn't even getting through the shell.
Yeah.
So not all of them. Some of the younger ones punch through, and then they get to swallow them, but then they break them up. But some of the older ones they just can't do it.
Yeah. So it comes down to like a lot of predation and just their tough existence in those ephemeral wetlands limits their age.
Yeah. Well, it's a case if you want to reproduce, you got to do it quick,
Yeah.
and
Hard time.
you're not going to have a lot of repeats.
Yeah.
So you know that because your chances of dying from this clutch to the next clutch is pretty high.
Yeah.
So you just put everything into reproduction. They have much bigger clutches than most animals of that size. So I think that's the thing. It's not an adaptation; it's a response.
Response.
The cumulative fecundity, there was some analysis I looked at that was just ridiculous. 1,040 eggs or something like that.
Per lifetime.
Yeah, right.
That's insane.
Compared to something like a Blanding's turtle.
Well, and to put it on the scale we did where they start, you're putting eggs in, and way down here, after they're done and gone, then you're still going down, and this is Blanding's just getting started. They're 14 to 21 years old when they mature in Michigan on the Georgia Reserve. That's not every population. But anyway, it was quite a contrast, so we were lucky to have it. And I was lucky to be asked to be involved in it.
Right. Something else related to just as parental investment and female investment in it. We've had some conversations with a few like grad students now looking at pre-zygotic discrimination of female turtles can potentially discern certain sperm types and kind of what they want to do with that. And
I'll believe that when I can see it.
Yeah. I that would be something to. It seems like maybe there's some analysis for that, but tough to really visualize.
Really tough to do, and to do it such that you could make a claim like that.
Right. Well, it's interesting. I mean, in terms of just investment prior to production of an egg, that's something that's interesting to think about in terms of phenology and how that may change depending on seasons and how well a female can. Well, even the question of how much does the female care in a given generation to produce the highest quality offspring, and that goes back to those general ecological concepts. But I'm curious, what do you think about? I mean, are females trying to produce the highest quality offspring consistently, or what's going into that investment for follicular development and while the egg's being produced?
Well, in the best world, you would say that something like that could occur if the female could predict what this year, the rest of this year and next year are going to be like, and they can't. So you're already hamstrung to try to make it into any kind of a response adaptation to this, because they don't know what this is, and so that's the argument that it optimizes, and then I believe in turtles occurs, but I don't. It's optimized in just in terms of the egg size and the egg number, but of course egg number varies all over the place, and just about every turtle you look at. So it's not fixed or anything, it's just resource controlled and all those things impinging. But a lot of people don't seem to know the difference between the word parental investment, reproductive investment, and reproductive effort, and they talk about it to the place where I get confused, and I quit reading. If I get that kind of sentence, I just don't go any further anymore. I don't want to read that stuff that's wrong because they use the wrong words. It's okay to make a mistake, but when you use the wrong words, and parental investment is energy that you invest in this offspring A, and once it's invested there, you cannot invest it anywhere else. Parental investment is you're investing across all these animals. And then reproductive investment is, or effort, and that's another term that gets the effort versus what should be used. But anyway, that investment as a portion of the whole energy budget almost never measured. I don't know of anybody that's measured that really in invertebrate, long life vertebrate, or anything else. Doing that takes a lot of finesse and a lot of work, and I don't know that anybody's done it, but reproductive effort's still a good concept. It just, I don't think it's well supported, well documented rather than supported.
Right.
So the right words matter, and in science they should matter a whole lot.
Yeah, the semantics of, well, maybe not. I mean, the actual exact definitions of things is that's a really important claim, and I've been dealing with a kind of a larger analysis of the non-native turtles impacting native turtles, and just you have to be very precise in that area specifically, and kind of parallel. You can't, going down to what's an invasive species versus a non-native, and thinking about the nuance, kind of how those definitions interact, and in ecology, it's something that's extremely important, I think.
In all science, it should be. If you can't define it, you shouldn't be studying it, for God's sakes. And the words count. And demography is pretty well butchered. There's a bunch of words that get really bad, but life histories, my God, I've read definitions of that made me start laughing and run in another room to tell Nancy what a life history is. This is what I've been studying. And one of them is the things an animal does today to try to make sure it lives to reproduce next year. That's a life history. Damn, I didn't know it all these years I've wasted. No, I mean, it's really... Okay, enough of that.
No, I think this is interesting. I remember, I don't know when this was, but Kurt Buhlman gave a speech at one of the past conferences, and he mentioned that you had made the distinction for him between natural history and life history. Maybe you could just say, I mean, what is what is that major distinction?
Well, natural history was not really well defined, but it was a class of people that did natural history, and natural history is everything the animal does. And the problem with natural history is they would write papers with 1,000 records and ask no questions. They were question-free biology, And so eventually that burned out and got a lot of, people, boo, they did, rather than just say, well, they were the start of this, even if they started and did it wrong. They started the interest, and even the bird feather collectors and that made some contribution to our knowledge about birds, even though they killed most of them. But it just, natural history, I wanted to be a naturalist, and that was part of my goal, but I was not going to let it be up here in science, on the bottom. Science had to be at the top, and that's why I thought, well, evolutionary ecology, man, that seems like a way you can do real biology and natural history, and measure and record things, but to try to use everything you're doing to answer a question. And that's the difference. I'm answering questions as much as I can, and God, this data set is full of stuff. And I don't know if you know, I'm all of every page, every subject, every data, the x-rays are already archived at the University of Michigan. There's almost 6,000 x-rays there. And the nesting sheets and the nest data will go there. And the nest sheets have the survivorship tag to them and how many babies came out and so on. That's all in the data set too, the life history, the master set. But that's going to be there, all the captures, all the measurements, everything we did and how we did it. And it's a lot of work giving your data away. And here's what I'm doing is I'm trying to get my fear level down, because if the modelers get it, particularly the nesting data, they're going to screw it up. That's a really complex data set, and nobody wants to read details anymore. So I'm doing the best I can to get it documented. I've had some help from informatics people to tell me you're not saying enough. You need to write more. But anyway, that data set will live a long time, and will be producing papers long after I'm gone.
I think we should get into talking about kind of the new trends you're seeing, but that hits on an interesting point. I'm working on a few projects with some people that are computationally, I think, very astute, but there does seem a lot of times like you put it into a Bayesian model or something like that, and then you write up a very basic report about what the numbers say, but it doesn't tell you much of a story at all. So I'm curious, what do you think, because those tools are important, but what is it that a lot of those, the modeling approach is missing that needs to be there, and how should we kind of think about making that interpretation better?
Well, one thing which surprises me is if you want to validate some of those models, the Michigan data set is a great place to go to get the input. The first time the input's real, it's actually measured, and you can go get the sample sizes and so on. I mean, we're talking thousands of nests and all those x-rays and all the data on what animals did every year, and in terms of reproduction and so on. Reproductive frequency, by the way, is the hardest thing for field biologists, the hardest thing to do. You can do it in captivity, but then you don't know what it means. But to do it in the field, our fence comes pretty close to it, because we walk it every half an hour for the whole day, and that doesn't say we didn't miss some. We had trees fall on the fence, we had deer go through it, we had all these, just like anything in the field. It ain't perfect, but we were on fixing it this the first round in the morning. We carried belt packs with clippers and wire and so on, and we would fix it on the spot if we could. So, but yeah, showing that something did not occur in a field situation is so close to impossible the best you can do is something like we did. We tried our best to make it so you can believe the data anyway.
Well, right, it's almost like ground truthing models, right? You need to, the field, there seems to be kind of a loss of connection between the people that interpret the results and the people on the ground doing the field work.
Well, the people that, the von Bertalanffy growth curve, there must be 100 papers out there. And go back, particularly the early ones, they got a little bit better for a while. But there's the curve, and we ran the von Bertalanffy model, and it fit the turtle. Well, let me look and see if it matters. Tell me why fitting the curve. You think that was what the turtles did it for? That's what it sounds like. And I honestly think the von Bertalanffy growth curve has destroyed the understanding of turtle growth, maturation, and both growth, juvenile and indeterminate, because nobody used them to generate questions. And when you do what we do, we found lots of questions. I mean, they're indeterminate growth. The thing is, do they have indeterminate growth or not? God, I remember being taught indeterminate growth. It took less than minutes. Well, this is indeterminate growth is when they keep growing, and determinates when they stop. Questions? Okay, new topic. It was done. I mean, it's like it wasn't interesting to anything, and I didn't realize it at the time. I was busy doing my own thing, but it's far from that. And I've got a snapping turtle paper coming out with Jeanette McGuire, where we do the male reproductive success, another thing that's been neglected mostly because of technology. And we've got that coming out with, that'll be a pair. We have a pair for painted turtles and a pair on blandings, and now we're going to have the first one on the snapping turtles. And indeterminate growth plays a part in it. So let me just tell you what that means. So indeterminate growth stops, it drops by, say, just pick like one of them, 7 to 8 millimeters average growth from hatchling to age of maturity. And then growth slows, but actually it's like a knife blade. It shuts off. There isn't any growth to speak of. But then indeterminate growth takes over, and for all three species, 2 millimeters a year. Think about how long they would have to grow as a snapping turtle till you could add one egg into that closed basket. And add the second one is not even thinkable with the mortality rate. You got to discount everything they waiting, and so it's really that. But then when these animals get out, snappers get out a bit, another 10 to 15 years, they just stop. And some of them stop earlier. In females and males, they stop growing. And so what do the females do? This is an interesting thing. So everybody finds a relationship between clutch size and body size and clutch size, so they're correlated. But in snapping turtles, a couple of populations and smaller sample sizes, they didn't find any relationship between clutch size and body size. And I was looking at that and I was going, what could that be about? And when you think about it, we're saying all the way along it's body size's influence on clutch size. What happens when that inflection comes to no growth? And sure enough, you look at that group of females, and there is no relationship to clutch size, but there is with egg size. So even though she can't wait that long, almost at no growth, you can't do that anymore. You can add a little bit to each egg a little bit to each egg every year. And that's what they're doing. They've switched their investment to the egg size. And that's not an adaptation, that's just a constraint to reality. So anyway, very exciting to me to see these relationships coming up, and that's what I'm going to talk about tomorrow.
That's really interesting. So is it that you're seeing that the egg size kind of plateaus like you'd expect with an optimal size, but then it starts increasing at the upper half of size distribution with age, or
When they're young, the population is young, full of young females. You get a relationship between egg size and body size and clutch size, and
it's all
it's there. They're different slopes, but you get a different relationship. But then when they get older, it's 15 years, but it's not. When I say 15 years, that's just where the majority of them go. There are females that quit growing a lot earlier than that. But then when they grow at that rate, which is about 2 millimeters a year, then all of a sudden they go to 1 millimeter a year, and they grow at that rate for a little while. And then the really older ones, they don't grow at all. And within some of those other groups, particularly the last two, you get some that quit growing in this group and some that wait until out here to do that. But all these relationships are, which if you're talking body size, you're talking time or age, same thing. It just depends on where you start, and growth. It determines the body size, and we've studied body size galore, but we never looked at what made that body size. And that's what we decided we were going to do. And so we measured height and and width on the turtles also. But that's the kind of thing that the allometric people love to study. And someday they'll find the data set and maybe they'll do something with it. I'm not interested in that.
Yeah. Well, the other thing too is I'm curious about with just talking about egg size is the pelvic aperture.
Oh,
and
yeah.
It seems like that's a constraint, but that seems kind of like a hindrance. Why is it that the pelvic aperture is a constraint? You'd think that would be something that was selected against over time.
Yeah, well, it's just that where the constraint really is significant is in short-lived animals and small animals. That's where you see it. Big animals are just, the reason they fall into categories is if they mature early, they quit growing earlier, and so they're kind of in the smaller group. But painted turtles, they have a pelvic aperture length that grows with them. So a bigger female has a bigger aperture. But do I think that's some kind of an adaptation? It's just if you grow, every bit of you gets bigger, and as it gets bigger enough, then you can do something different. But you have to be careful, which we've seen animals with, they couldn't get the egg through the pelvic opening. They would be stuck. We'd oxytocin them, and they'd lay so many eggs and then quit, and you'd pelt them, and they still have eggs. And so it's a constraint. It's just a physical or an anatomical constraint, an age-based. And they can grow out of it if you're at the border. But after that, they don't rapidly start growing bigger eggs. They're on the same plateau with egg and clutch size. They don't go like this or anything. It's not that kind of a thing. That turtles, I think, just do what they know that they're the end of 200 million years of being on this earth, and they just do it. And I think the more you think about it, and just to jump to nesting, I thought my nesting paper in '87 was just like I wanted it, and it was pretty good. It gave survivorships. It talked about all these things. So I thought, well, we'll redo the snapping turtle thing. And I started looking at the data, and the more I looked at it, and I can tell you what, it doesn't look anything like that paper, and it's 50 pages long. And it's been the most fun and the hardest paper I've ever written. It's just every time I think I'm done, I find something else that's related or influential, and I'm not looking for any more. I quit looking a year ago, and then I find something and I go, oh damn, get in, put in a new figure, have to adjust everything in the tables, but anyway, it's been fun, and I hope to finish it this year before fall. It's just a discussion that's got to be done. So, yeah, that's how I think turtles basically operate, and the nesting thing with the snapping turtles. So I want to think about, people have claimed that the turtle should be able to assess nesting area quality. They nest close to water, the majority do, except those that don't. But the majority nest close to water. I mean, 25 meters, the majority, probably 25, 30 meters certainly encompasses 75% of the nest. And so if you have a high quality nesting area and females can assess it, what's going to happen on that nesting area? Nest densities are going to go. And with nest density, here's predation rate falling right with it. The denser the nests, the higher they're destroyed. And they're already being destroyed at an average of 26% is the long-term survivorship average for the 30-some years of nesting. And so if you're doing something like that and assessing it, which people have said they do, then it's not all good. It might be a good nesting area, but it's not a good survivorship place. And then snappers nest in the morning, through the morning, and they nest in the evening into night, real late at night. And the fact is into the next morning, some of them. And you say, well, somebody explain to me why a snapping turtle that has all this ability to predict and assess and do all this, why would they nest at night when all the raccoons come out and the foxes and everything else? And lo and behold, survivorship night nests up here, morning nests here. So that doesn't sound like that they're assessing and doing all these things to me. So why that's still in there? It's only about, on the Georgias, it's less than 20% that nest at night.
Interesting.
And there's no body size difference.
Right. I mean, it seems like you've highlighted it in ecology now. It's there may be so much reliance on pattern finding that the questions asking why is kind of getting pushed to the side, and just quantifying a pattern and describing it as kind of the primary objective, which is a loss of information. But I mean, if you think about turtles broadly, we've touched on a lot of the specifics, but delayed sexual maturity, interoperance over within a season and across seasons, and sort of this long-term, just kind of life history overall, and the question of why behind that. I mean, what? And you've sort of said this is just 200+ million years of evolution, but what are your thoughts on why that tactic has, at least to this point, been selected for, and is the case with turtles now?
Shells work. Certainly, I would guess if you peeled the shell off a snapping turtle and put it out to nest, it wouldn't last very long. I know that's ridiculous, but it and the same thing with chicken turtles. They opted for this incredibly thin shell, and they can't box up, and so anything that catches them, otters and raccoons and foxes and stuff, they can kill them fairly easily, and they do. So their whole thing is live fast and reproduce, grow fast and reproduce as soon as you can, because a lot of those turtles are, I forget, it's a very low percent, below 20% live to the second year. They reproduce 1 year in the fenced areas at Ellington Bay and Dry Bay. So your odds of getting one clutch per lifetime is pretty good, but nobody knows a lot of concrete, really good survivorship data for juveniles. Just broadly, they like Kurt's paper on the ecology of the turtles. It's pretty good. It's got some good information in it, but that's what it's about. I mean, if you can box up like a Blanding's turtle, we have very few killed, but amazingly, we still have big adults killed by raccoons, and occasionally probably by foxes looking at the teeth marks, but it's hard to say. Raccoon tooth doesn't look all that different, but just the pattern of the bite thing. But yeah, one of the sexton turtles, at Cattail Marsh, she was about 76 years old, no, 67 years old when she died, and she was killed by a raccoon, and she just did something wrong. She didn't box up fast enough, or he ambushed her and got a leg out, like a rear leg, and just started chewing, and I don't know, we weren't there, but the person that was watching the nesting area saw it saw it in process, and called me, and I went, oh no, I picked that animal up, and I'm just starting to get the aging stuff going, and here's the sexton turtle terminated in the study. So, yeah, I think that the shell is it. I mean, that's the thing that sets them aside from a lot of things, most things.
And that's mandated a lot of sort of different strategy overall to kind of just surviving and reproducing. That makes a lot of sense.
Yeah.
Everything's kind of linked full circle.
You're never going to see a rabbit that's 60 years old.
Right.
So,
Well,
and senescence,
right.
they've had all those years with the help of the shell, and you can't avoid senescence. W.D. Hamilton in his book or paper said senescence always creeps in. I like that. It always creeps in. You can't say they don't senesce because it always creeps in. But anyway, he pointed out that a lot of the things about aging and senescence, and there's all a theory about that and wild things, and Tuck Finch from California had those symposia for 6 to 8 years on the ecology and biology and so on of long-lived organisms that delay senescence. So you maybe you can't stop it, but you can delay it by doing X with your calcium metabolism, or Y with your nervous system to prevent degradation of your nervous system. But he pointed out it's system-wide. When you start, and I know it's system-wide. When you start aging, it's not just one part of you. It's pretty much everything. And then the guy that came up with it's the golden years. I think he was talking about a urinary problem, because it's not anywhere near golden, believe me. I'll take 20 anytime.
Yeah. It's that is Craig Stanford has mentioned that we should talk to you, that you'd got an award in gerontology for your work with aging of turtles. But I am curious, because I mean, turtles chicken turtles, and some of them don't live long, but Blanding's turtles are a great kind of counterexample to that. But the thing that's interesting to me is, okay, they live potentially as long as a human. We're long-lived as well, but they don't physically age that much. And so I'm curious kind of what the basis for that is, or what you think turtles can teach us about aging in general.
That they've been able to delay it, and they've had many, many thousands of years to delay it, the conditions that cause it, and so they can keep reproducing when humans stop. And there's no good reasons for humans to stop except that the aging process is beginning to change the reproductive process itself. And so, and also, for humans, you've got 20 years to deal with your kids. I mean, maybe not early, but say 10 to 15 years. And if you have kids and you die, and you're a monkey or something, they're not going to make it. I mean, why did you bother? So, it's when you start having parental investment, you have to look not just at when they quit reproducing, and the age of penalty extends through caring for your previous offspring. So, yeah, Finch was I never asked anyone about who you said. Who'd you just say that did the thing about aging? Stanford, right?
He had mentioned, because we talked to him earlier today, just that you had gotten an award at gerontology for
Ipsen.
your work on it. So.
The Ipsen Foundation Award.
Yes. Well, I mean, just thinking about it, just general ecology discussions are interesting because you can kind of go any direction. There's no limit to how to think about it. With snapping turtles specifically, and it seems like this data is at least 40 plus years now, and you had a pretty seminal paper in 1994 on demography of snapping turtles, another life table analysis. I'm curious how the view from that has changed to now with all of the decades of data that you have now.
Well, the foundation of it, the Blandings and the snapping turtle paper, the two, and with the added influence of harvesting on snapping turtles, those two papers basically set the model for delayed aging, and that was pretty much the goal of it. And there are parts of it that change, obviously. And those carefully say we did not. All of my papers carefully say we're looking at actuarial senescence. We're not looking at brain degeneration and chemicals changing and all that's going on. We didn't say that, but what can we measure? We can measure a downswing in reproductive output. That's not good, or an upswing in mortality. And when we look at the Blandings, they're doing the old ones. This old lady had 11 eggs, at 94 years old. And what's the mean clutch for the whole population? 11 eggs. So I'm sure that's just a coincidence. But the same with the snapping turtles. There's no indication that major things are changing in the oldest ones that are out reaching 70 and beyond. They're fine, and we have good sample sizes. I can tell you, we're talking in some of these things. Most of the things we're talking over 1,000, or close to 1,000, or over thousands. So, captures, I can tell you that just because I like to brag about the study. There's 30,000 plus or minus. I haven't done this year's stuff in or anything like that, but they're right around 30,000, but not less than 30,000 captures of the animals, and then the nests of all three species are in somewhere around 5,000, I think, and X-rays are around 6,000. So that, and we do our best to catch everybody every year and get every nest, and that was the goal, and that was always my goal. And we kept it as a goal, and we never met it, but that was part of the game.
Seems like, yeah.
This year we're going to do it, damn it. We're going to do it. And then they'd get thinking we would do it until they were out there for a week or 2 weeks, and then they go, we're not going to do it. This is hard. But we've got a other thing that's happened that we didn't plan it. But we never thought about tree growth and autumn olive, and our nesting areas, due to autumn olive primarily, but a good 15% or more is due to tree growth and shading. But we went from 17 to 20 acres of nesting areas that we worked every day to around 7, and there's not a single thing left that isn't human. It's lawns, it's roads, particularly the intersections of dirt roads, that little triangle it forms, and so on, and lawns in there, and any place that's dug up, and of course as nesting areas collapsed, the raccoons had less place to go to look and find, and nest densities are up on it. Fewer of them, smaller ones left over. Survivorship or nest mortality is getting way up. And right now, in general, when I did the Euler equation last for the survivorships, you plug it into the life table, and there's not a single one of the 3 species that is not right now, according to the calculations, which are really good, are getting recruitment high enough to maintain populations. So, and that's sad. Think of that place being that bad, and we're working on it. Since 2016 we've been restoring nesting areas, and because of the SSAR field trip to the George Reserve, the new director was wonderful. I can't wait to get a chance to talk to him again. He's been in Europe and all of the places that people from Michigan go, and but I dealt with him when he was 2 years that he was director, and then he got promoted, and now he's back because he didn't like his higher up jobs, and this was the first year. But anyway, he's a supporter of burning, and he gave us permission to cut trees down on the George Reserve. Unheard of. 10, 15 years ago, you couldn't get permission to do that. We did it. We would cut it up and hide it when we put it down. But we couldn't do really major job. And now the caretaker of the reserve, one of his tools is a tracked bobcat with a tree masticator. Do you know what a tree masticator is?
Shredder type of thing?
It's a big thing, and going out, and there's this huge drum with carbide teeth that spins at 2,000 RPMs. And the bucket, when it tips, there's a bar this way, and here's the drum, and you can push the tree. You put it up against it, and so it's up here, and you push the tree, and then you push the whole thing in, and it pushes the tree away from falling on you. And then it comes back, and in a tree, let's say an oak tree or a cherry tree that big around, and he'll go up and get up, and he always cuts them where he knows he can get to the top, and he goes, and the tree's gone right to the ground, and that's like no work at all.
Yeah.
But you can't watch from anything but about 1/8 of a mile away. There's stuff flying, and the first time I went there, no, Justin, you got to go back by that tree up there to watch. He said, you can't believe what this thing does. And I still got hit by it.
Oh, really?
But not mostly. It was spent when it hit me. But yeah, I wouldn't go watch that without goggles now, without safety glasses on or anything. But that's great because he can also put it down and like this. He'll bring the bucket down and he'll put it down like this, and he'll use it as a lawnmower. Except what you're eating is brush, and you're mowing it, and that flies all over. And then we got to go in and clean it up. But we did 5 acres this year, which is a lot, and a lot of it was because of the field trip to open it up so they could see the wetlands and so on. You couldn't even see the wetlands on the Georgia River. You drive right past it, 20 feet away. One side, 2 wetlands, and the other side, 1 wetland. You're driving down the road, and you wouldn't know there was a wetland there. And I kept bitching about that. I went, let's get out here, and if you bring a researcher out here, they're not even going to know you have a wetland to research. And that there isn't much out there left. Old fields are all gone. So anyway, we're working on it. Believe me, we're working as hard as we can. We get as much done every year as we can, and we have to do research. They won't do this without us. They're doing quote research. And so the primary question is, who comes to the new nesting areas? Only old turtles, only new turtles, new unmarked meaning, and or both. And I go, oh, let me guess. Both. They both will be there. All 3 will be there. Trust me. I already knew that. So my heart is not in this kind of work, but my heart in the helping the turtles is all there. So I got to keep doing it. So anyway, they show up within 3 days. If you're doing one close to the wetland, 3 days you'll have a nest. They see that open area and they're all over it.
Interesting. So the decline, you think that the declines are mostly driven by some of those invasive plants crowding out?
Yeah, and okay, so densities are related to size of sunlit areas and open areas. So you have to have them sunlit and you have to have low vegetation cover, because even a plant, that grass that tall will shade a nest, turtle nest down here dug in the ground, it's shaded. So what you have to have is large areas, lots of areas, and then a multitude of small ones, sprinkled, separated, and that then you get enough going that the raccoons have to work again, and that's what we've been doing. And the autumn olive, you'd have to see it, it makes you sick. And Chris Dick, the new director's parents own a farm in Pennsylvania where he grew up, and their farm was invaded by autumn olive, and he goes over there on his long weekends and so on and helps mom and dad by clearing autumn olives. And so he hates it, so he's totally open to burning. Really good man, makes decisions. I asked him one day, I said, how did you get permission to clear this cattail, which is about 1.5 acres, cattail fields? And I said, how did you convince them? He said, I didn't convince them, I didn't ask them. I was put out here to direct, and I'm directing. You the man.
Nice.
You the man.
That's
I
good.
loved hearing that.
Yeah. I just something else. One other thing, and I think maybe we could get into some of the stuff that doesn't get into academic papers, just your perspectives. But talking about it, turtles have to leave the water. Aquatic turtles leave the water to nest, and that brings on different hazards, that sort of thing. But also the distance they're going. What is that correlated with in the environment? How far they go? How much of that is individual variation?
You mean among species or individuals?
I guess both, within and among.
Well, if you want to go, the majority of turtles, snapping turtles, nest close to the wetland. Yet 18 of them from southwest take a kilometer walk to Cattail Marsh, which is a very temperate. It's no turtles usually live in it. Juveniles do, but no adults live in the thing, and you can't hardly trap it. You can't get enough water to get a trap set. So we would dip net it and so on in the early spring and get as many turtles as we could. But they would come all the way from the west end, and they'd come over and they'd nest on the blowout, which is open. It was a glacial sand blowout, probably wind generated almost certainly. And then right across from that is Cattail Marsh, and then there was an old field, Cattail Field, and we knew they did it, but we never. You're so busy during the nesting season, they never really thought to look at it closely. Then, when I did look at it, there's some of those 18 that did that, and then a year later or 2 years later, they came to there, which is a 2 kilometer migration, and then they went clear to East Marsh, and they nested next to East Marsh. And then they came back through there and came right back to where the resident wetland is. And so there's, I forget how many hundreds of captures of those females. And I actually thought there was only like 3 that did it, but there are 18. And what was that about and why they did that? I've asked a lot of people and say, I'm totally without a good guess. Not even a guess. Why 18 turtles would do that and 90 turtles or so would never do that. And survivorship sometimes is better there because nest densities are lower. And then the ones that go to East Marsh, it's the same survivorship over there because the resident turtles are nesting there. And so the density is the same, and they just boost it a little bit, and so mortality rate of their nest there is just the same as it would have been if they stayed at Southwest. Another thing that squashes an adaptation, if you look.
It's interesting. And the predation too, some density dependence, but also it seems like the first 24 hours is kind of the gauntlet, and then after that you're kind of in the clear for the most part.
It's the first 2 days.
Okay.
And it's 86% in the first 3 days, but probably 70, high 70s are on the first day. There's so many of them that are in the minutes. The eggs are being eaten as she lays them. Raccoons have already been there, and the whole family's just fighting over getting their hand in there and getting one before it even hits the ground. And so, but the next day you get another hit, and then by the 3rd day, you know, if you make it through the 3rd day, you got a pretty good chance of making it all the way to the end of the nesting season. And nest mortality at hatchling emergence is essentially it's not significant. That's because, think about it, the one thing, and this is in the paper, if nest densities are important for raccoons to look for eggs, they've already made sure there's no nest density of surviving nests. So just what you'd expect. Very few out there and scattered all over the place, and very few of them ever get dug up. Just probably less than 5%. So that fits in right with the whole scenario with raccoon predation and fox predation. That they're focused while the product is there, and then after the product is there, they lose interest pretty darn fast.
Right. Interesting that in the human side of it, the humans as predators, you know, I think some of the stuff that you've revealed is pretty striking. 2% mortality or above that of adults, and the population will decline pretty precipitously with you can't sustainably hunt snapping turtles and that sort of thing.
They're the best at sustaining it of any turtle species I know of, but they can't do it either. But they can do it. They have been doing it. Think of all the years that Campbell's made soup from the alligator snapper and from big snappers and so on, and yet I'm not saying they didn't extirpate populations, but snappers never went out of existence or anything. They just may have crashed a population, but I think trappers are like same as raccoons. As soon as you get down there and you're getting one every other day, you pull your traps and go somewhere else, and that's one of the reasons they can do it. But then again, the other thing is the eggs. I mean, when mama puts one or two out there a year, or one clutch a year, but over a lifetime she gets 5 or 6 out there. That's a lot of eggs. Our mean is 26 eggs. Our high is 44. So, and they're small-bodied snapping turtles. That's the other thing is why are they small-bodied? And you go over and trap on Bass Lake and all the lakes surrounding the George Reserve, they're all bigger.
Yeah, a lot of interesting things to think about and future questions. I guess that's sort of the next thing is, right, you've got all of this long-term data and you've built off of this, and I'm curious the future directions. What are the questions in the ecology, life history overall that kind of are pressing now and you want to analyze?
Well, I'll tell you the missing link now on nesting, and I've got it in the paper, what we didn't do, and a part of it was at the end of 30, 40 days of nesting, you were incapable of thinking what the next step was. And I, of course, had a day job, it's about, I don't know how many hours down, 9 or 11 hours down south of us to drive. But we did the nest survivorship, but not as intensely as we could have. But what the last step that's right there, and it jumped out at me while I was writing this, and I went, how did you miss that, Justin? It was just a pearl sitting there waiting to be plucked. And that is, and it's such a good thing for masters, for a PhD. What a wonderful project. And they could find the right spot, and the George Reserve could be the right spot, but there are plenty of places. But to get nests survived, and I'm doing the age of the date of the nest, days to emergence, and then days to emergence to fall, really fall in November, and sure enough, early nests, earlier babies, more time on land before the first winter, and that's where I think the hammer falls. Is if you're late getting in, you're not mature enough to make it. Your mortality's way up from one that's had another 2 weeks, say, to get ready. Because we followed them up in Minnesota with the little bitty transmitters, and they do all sorts of interesting things in the shallow water along wetlands, the babies, and they move, and they keep moving, and some will sit and be the same place for 5 days or 6 days, and then they'll start moving again and move every day for 3 days and so on. There's a lot there, but to find out how much days to winter, how that's related to survivorship to the following spring, and you've got to do that in a place where you can take the hatchlings maybe from nests that you build, which is easy to do, and you can put them in as early as you want, and so on, as many as you want, and then follow them to emergence, and then take them and for different lengths of time from emergence to the fall, and put them in a maybe an enclosure or something, pond, but a nice, really nice small wetland would be best. And put them out in there and see who makes it to spring. I bet on earlier out, more survivorship. I don't know what the survivorship rate is from getting out of the nest to fall. I don't know. That seems like that would maybe be the longer you're out, the more risk you're at, but I'm not sure that would be true. So that's a question I would love to be back there trying to answer, and because it sets what the value of nesting early is, and trying to adjust maybe to the effects of spring temperatures. And it's not only spring temperatures, it's last year's temperatures that are important, because that's when you harvest all the energy you put in eggs today is last year.
So yeah, that's really an interesting thing to think about, and why. Yeah, just the question of why all females don't come up at the same time is interesting. You know, it's not that all turtles aren't Arabata nesters. It just seems like that could be a phenomenon that's consistent all around. And why is it staggered like that? This
year, our favorite neighbors, the Kaisers, are on the west side of the George Reserve. So the George Reserve fence and fire lane where Blandings nest, and then the fence and the Kaiser driveway. It's a long driveway in from the highway to a really nice place. And one fun morning, we were out about 1 o'clock on a Blandings turtle, and we were down at this end, and we were shooting up the fire lane. Well, that was up the driveway to the house, and so we do, count and watch, and every 3 to 5 minutes we'd pull headlights on and then put them right off because she's still there. But we didn't give her much time to get away because they can get lost pretty quick. But anyway, all of a sudden these headlights come roaring down the driveway, and it's Mr. Kaiser in his bathrobe and his 357 Magnum, and he wanted to know what we were doing on his driveway. Well, he got there and he realized we weren't on his driveway, we were over there. And so we introduced ourselves, and then he wanted to know what we were doing, and we told him, and he said, "You want to come up the house and have a beer?" And I apologized, and I said, "No, but if you we can do it. We just can't do it now. We're beat. We've been doing this for 20 days or whatever." "Oh yeah, well, I'll let you know." He said, he works at a nuclear plant, and he said, "Next time I'm in, I'll call you and we'll see if we can get together." So we went over and had a party.
Nice.
and met him, and now his daughter's living with him, and so that gets to this point of this little story. She just sent us a thing, and it's on my phone. And she sent it to Todd Quinter. He's gotten to know her more than I have because I don't work that area over there. I work East Marsh. But anyway, 15 or 18 days, I can't remember exactly, somewhere in that neighborhood, she sent him a picture of a Blandings turtle nesting in their flower bed. That's after our last one. We declared the whole George Reserve over. And then all of a sudden this turtle shows up, like, it was after I drove back to Arizona after the nesting there, went to the SSA, did the field trip, went to that, and then drove 4 days, and then it was just last week that she nested. And you go, what's that about? That's an interesting, we've had late nests before. Our rule is nesting is done when all three species, but for each species, but all three species, the overall nesting season is done when the last nest, and we're out there 3 days working our butts off for nothing, and it's good weather. It can't be, a cold spell or anything, and that doesn't count. We do it another 3 days until we get nesting weather and 3 days of it, and we can't find a nest anywhere, and we don't find any new destroyed ones. And then we say nesting season's over, and we've had ones 4 days later, 5 days later, that kind of thing, but never anything like this Blandings. So
it's interesting. Just the phenology, do you think that's shifting? I mean,
here's what I think: she was captured and taken home, and held, and probably in a box in a house or something, or in the garage. And then they let her go, and she ended up at Kaiser's, and she was probably captured somewhere right on the highway, between, somewhere near his house, and she just ended up at his house and nested.
Interesting. So maybe she was holding on.
She was holding on because there's no sand or anything to dig in a box, and
Yeah.
they wouldn't know to do that. So that's what I think, but that's just because it's so rare. I mean, this was my 40th year there.
Wow. Well, and I think that's a good segue kind of into. We like to explore the adventure side of things. It's got to be the longest time that someone has kind of worked on the same project with turtles. Or at least high up there in the ranks of those. And I'm just curious, in all of your adventures there, what are the things that stand out to you the most, and sort of the highlight moments at the George Reserve, and maybe also other places, the Chiricahwas, Weaver Dunes, other places you've worked.
Well, each place had its good people. We had bad people, but fortunately, the good people that worked temporarily on the thing way outnumber the bad ones.
That's good.
And you have to expect to get some bad ones. I mean, that's just part of the game, and but I had read 3 Minute Manager, and how to manage a group, because when Don and I were there, we had one person working for us, and we did, so we just did it. And we didn't have to think about other people at all. And then when he went, I had to round up volunteers and the few that I could pay, and we did it. And so I had to manage a group. And during the nesting season, that was 6 to 8 people. And so you had all these things happening, and there were lots of funny stories in that. But an adventure, I tried to remember the other day. I had one somewhere that was so bizarre I couldn't believe it, and I thought, oh, I'll tell that one, but I can't come up with it right at the moment. But yeah, I mean, so our place, if you put traps out, muskrats, chew a hole in, chew a hole out, chew another hole in, another hole, and go in and chew another hole out. So you'd have 4 holes for a muskrat that went in there and couldn't find anything to eat, because our bait, we had decided early that we can't feed the turtles, because we're going to be here all this time, and if we start feeding them, we're going to affect growth and so on. So we can't feed them, so we put the Nalgene jars in there with holes drilled in them, so they didn't get anything they could smell it, they just couldn't eat it. And that was our best capture. Cleaning up in the fall, power wash all the traps, and then spread them, the 3 hoops against the center hoop, make a little triangle, and let them out on the lawn to dry. And Nancy and I came home, and we started to get the stuff out of the car to go to the Hill and Dale house, and all trap starts going like that. And it had a great St. Bernard in it, about 2/3 grown St. Bernard in this collapse trap. And I went, oh, that's got to be a world record. I don't know of anybody I've ever heard that goes to St. Bernard in a turtle trap.
Wow.
But yeah, that was fun. So we just put the word out and got a thank you for getting their long lost puppy home.
Yeah, the animal control, you did their work for
Yeah.
them. That's really
That was
interesting.
funny. But there were other things like that just happened. Matt Cross showing up with his x-rays, to me, like, whoa, there's some heavenly interdiction here.
Yeah.
I mean, that was too good to be true. So down at SRL, adventures all usually centered around Whit Gibbons.
Right.
We always talked about the angel on his shoulders, guardian angel, and we always wondered, here's Whit, how big is the envelope? Will it be over here past me? because he was something else as a youngster, and I'm sure he's not much different now. So we had lots of adventures out on boats in the coast with no lights, and we'd get back after dark. Lightning storms out there on the way back. One of the really good guys at SRL, we got back and I'm trying to think, Garfield Keaton. I said, Gar, I said, why were you sitting on the gas cans with all that going on? Everybody else is terrified. And I mean, the bolts of lightning are going off and you jump, and so he said, if we were going to get hit, I wanted it to be total. I'll go up with the gas. And
Nice.
I went, yeah, okay. That was one of those that there was about 8 of us in the Big John boat. So anyway, it was always good, always amazing. And he always talked to people in the back seat, driving down the road. And things like that you just go, how long are we going to be lucky? But he never had any major thing. So he did have that angel. I just always wondered if I tried to stay fairly close.
Right. Stay, somewhere in the coverage. That's interesting. I guess for your perspective now with turtle ecology is, I mean, what are the things in the realm of maybe general ecology, turtle ecology that have you optimistic, and some of the things that maybe are trends that make you a little bit worried?
I think, and particularly since you said there'll be students maybe listen to this, that I told all my students, most all my students, but the ones that seem to didn't come with the project, that the largest source of good questions can be found in that HERP review. Those little bitty things, I saw this and I saw that, and I've been told things like that by people while I was doing the Minnesota work on the Mississippi River, that soft-shell turtles hunt in packs. And I'm going, okay. And then this guy who's a DNR person told me the story, and I trust him because he's a great guy. He raised tomatoes and brought them over during the nesting season up there, and we'd eat tomatoes, and I love tomatoes, fresh garden tomatoes. Oh, I could eat as much as he'd bring. But anyway, he told me that they were camped on a river, a stream, and he said we were all there, and we had a fire going, and we had backlights. We were playing cards, and he said, somebody said, look, there's a soft shell, and he said, look, there's another one, and there was a waterfall, and the soft shells were coming up the thing toward the waterfall, and pretty soon fish started jumping up, and it wasn't a tall thing, and jumping up, and some of them make it, some of them come back down, so on, and the soft shells went right up, and were gone for about 15 minutes, and then here they came and back over the waterfall, and they went down to the other end, and then pretty soon they started back up the pond, and I said, oh my God, you have to write that up as a note. I mean, that's fine. Well, I have to get more data. I said, no, you don't. You're going to write that up as an observation, and somebody will see it eventually. I mean, those kind of things are pearls. And then he saw turtles at the bottom of a pond up there in the middle of a winter with ice thick enough to walk on, and he had an auger, and he cut a hole in, and he looked down there, and he said the bottom of the pond, which was not too deep, maybe 10, 12 feet, and he could see all the way to the bottom, and he said it was just loaded with turtles on the surface. It's like 3 or 4 species of aquatic turtles down there. And of course I said, oh man, you got to write that. No, I never got them to write anything up, and you can't just write it up because you heard it. You know, you
right.
can't do that. So those are the things I think that's an absolute resource for people trying to pick a project. And there's 2 on turtles that I think need looking at. And what's that about? And it might be hard, but there's a lot of them that seem like good questions and not too difficult for a master's degree. Not quite complete enough for a doctoral thing, but for a master's just fine.
Yeah, that's great. Interesting advice. I guess that kind of leads us into the sort of last question we like to ask is, and that's some advice already, but just general advice for students looking to make turtle work a career. I mean, maybe just what would that be?
Well, first of all, you know in your lifetime you will not get all the questions answered, so you'll never be out of a job, and obviously part of your job is doing the research, and so you have to like it. But you may have a job like I did and do thermal biology and radiation biology and who knows all what I did down there at SRAL to keep everybody happy. And that wasn't my greatest love, but it was certainly not bad. So look for good questions and ask questions. Another thing that I find is people don't seem to ask questions anymore. You know, somebody will start a snapping turtle project and I'll start reading and I went, oh, you're off on the wrong track with that brooch. I mean, we showed that to be worthless, you know, and you'd think that if you're going to do a project on a species, you'd look up who's done the research and what they've done, and then try to figure out what needs to be done from that and how they did it in particular. It's a lot of people don't write up their techniques, and I'm one of those that don't do that very often. But I told a joke once about why haven't you published that thing on aging or on marking turtles that you developed? And they said, you gave it to the people out west and they really liked it, and why don't you publish it? And I went, well, so nobody else can do as many turtles as we can. And these people just went, no, I'm joking. I'm joking. That's not even in my thing. I don't need to do that. And anyway, and I said, I will publish it. I'll publish it soon. But that reaction was striking.
That's funny. Cutthroat.
Yeah.
Right.
The time I do research is to get something on somebody else, or that, no, zero-sum game is dumb.
Right. Well, I think we'd like to end every discussion with a turtle trivia question. I don't know if you've got it could be as obscure as you want, but just a random fact you want to throw to us, see if we can answer it. We could throw in your way too, however you want to do it, or if you need to head out, we can.
I think there's a story, a little bit of a story in their eyes of different species that might make a good project, and I'm not up on that. I'm not. But some time ago, that the issue came up about some turtles have eyes of different colors. They have eyes of different shape, and so on. And it seemed to me that nobody that I knew of has done that. And there's certainly still some work to be done on vocalizations. There's lots of work. That's a new topic, and it's amazing how widespread it is, and we never knew it. And I'll tell you a story. Me and Don Tinkle were in Hidden Valley, and we're up on a ridge, and we're watching a picton nest. And she's nesting down there, and we're up on there, and we're whispering and so on. And then the question came up: can they hear? Some people said they don't hear them. anyway, so then as we talked, we forgot to whisper a little more and more, and all of a sudden, there was a pause, and then one of us said something, and that turtle down on the fire lane about 25 feet away, 30 feet away.
Looked right at us.
Right at us, right dead on. And she just looked for a while, and then she went back and finished her nest and got out of there. That was funny, though.
That's funny.
Like, I can hear you.
And one other thing is I have this really firm, experience-oriented observation that aquatic turtles that spend more time on land are way more intelligent in a lot of ways. And there's observations on that, and Whit'll tell you one that don't ever let him know that I repeated it because I've always told him I don't believe it. But the director of the Kellogg Biological Station, they were invited over to dinner, and he had a box turtle that had been a pet, had been with them for years, and he goes, well, the box turtle loves ice cream. And he said, come on. He takes this thing in his spoon. Ping, ping, ping. Ping, ping, ping. Out comes the turtle, and he gives it the thing. And he said, one night we were over there, and the turtle, he kind of withheld the ice cream. We can wrap this up right now. He sort of withheld it, and the box turtle stood up on its hind legs like this. And I went, okay, you've gone beyond now. No, it really did happen. I mean, you ain't gonna convince me of that. And so I don't know if he remembers that, but I've told that story about that box turtle, and then box turtles out in the West, they're ranch foremans and owners that they're not pets, but they come every year. The same individuals come basically the same time, and they water and feed them, and they hang out, and then they leave, and then next year, bing, they're there again. So I think there's a lot to that, and I think wood turtles probably have it, box turtles, blandings to a certain extent. They don't spend as much time on land, but they certainly make long distance overland movements. So those are good questions too. For a person who wants to deal with that kind of thing in turtles. I thought I'd do that on my retirement. I really did. I thought, boy, that's what I'm going to do when I retire. I'm going to work on that. But I've got more than I can handle now.
And it's something that's come up a lot in our discussions is turtle intelligence and social behavior for future questions. I think it's...
I know. I see this turtle personalities.
Yeah. Right.
You can always know the ones that they have the little things that look like whatever those collars used to be that folded over. Really well dressed.
Awesome. Well, I think we can finish off if there's anything you'd like to finish off with. Or
no, I'm talked out.
That was awesome. Thank you.
That was
Thanks
great.
again. It's an honor.